Where to speak or?
Yes, sir.
Oh, you didn't.
Yeah, right, sir.
Introduction. Okay, very good afternoon to all of you. I hope that you are enjoying this Principles of Organic Synthesis course. If you have any doubts, the assignments or the material, you can try to ask the questions.
So we can discuss the questions which is in the Google sheet.
This, Okay, explain the hard and soft nucleophile and electrophile, and also explain how the homo-lumo interaction takes place. So I can so if you consider Grignard reagent, and organocopper reagent, so this is hard nucleophile, this is soft nucleophile, and when you do the reaction with, for example, aldehyde, now let us take this alpha beta unsaturated ketone. When you react this substrate with the Grignard reagent, it can undergo addition at the carbonyl group. Since this is a hard nucleophile, you will be able to get this as a major compound. On the other hand, when you add to the Grignard reagent copper halide, then you will be able to form. So this is a soft nucleophile since it is bonded with copper. When you add this reagent, then it can undergo 1,4 addition reaction. This is because this is more electrophilic comparing to this. This is a soft electrophile. Therefore, the soft nucleophile undergoes addition here, and you will be able to get 1,4 addition product. This is a good example for the hard and soft nucleophile. And similarly, this carbon is more electrophilic comparing to this. This is also an example for the hard and soft electrophile. Now let us discuss about the HOMO-LUMO interaction. If you take cycloaddition reaction, if you take 2 plus 4 cycloaddition reaction, let us take this example. And when you heat this, you'll be able to get the cycloaddition product. And if you compare the reactivity of this dienophile, you can also replace, here you have the electron withdrawing group. In place of that, you can also put electron donating group like this, or methyl here. The electron density on this double bond is increased. This also can undergo addition reaction to cycloaddition reaction to give this product. However, if you look at the HOMO-LUMO of this, for example, if you take this HOMO of this diene, you can write like this. This is I1. This is I2. This is a HOMO. So this is I3 and this is I4. Right, if you see the energy level, this is a HOMO for the diene, and similarly you can also write to try to write for the dienophile. This is a HOMO of the dienophile. This is LUMO of the dienophile. So the reaction takes place between these two orbitals. Now if you look at here, and this reaction takes place, similarly these can undergo reaction. These two, the LUMO with this HOMO or this LUMO with this HOMO can take place. And what happens, and if you look at here the substituent present in the first one, methyl acrylate, this electron withdrawing group, it can reduce, if you have the electron withdrawing group, it can bring down the energy level of this LUMO. If you have the electron withdrawing group, if you see the energy gap between this HOMO and LUMO is reduced now, the reaction can easily take place. Therefore, if you compare the reactivity of methyl acrylate with this ether, vinyl ether, and this will show greater reactivity. The reason is that when you have the electron withdrawing group, the energy level of the LUMO orbital is reduced, and it can easily overlap with this one. You can make the sigma bond. On the other hand, if you have the electron donating group like methox group, it can increase the electron density of this double bond. Now the LUMO of this vinyl ether can increase. So the gap is between this LUMO and HOMO is increased, therefore it can show lesser reactivity. This is an example for to understand the HOMO-LUMO interaction to make a carbon-carbon sigma bond. Now, this session is important for CSIR NET chemical science exam? Yes. And there will be, we will study so many reactions like aldol reactions, definitely there will be a question. This course will be very useful to you. What is a selective, stereospecific, regioselective, regiospecific, and chemoselective reaction? Now, I can delete it. Now let us stereoselective and stereospecific reaction. Now let us take this one. You have SN2 reaction. If all of you know very well, SN2 reaction. If you can call it as stereospecific reaction, because if you do reaction with optically active substrate, you will get the inverted configuration. So 100% you will get single enantiomer, then you can call this as stereospecific reaction. For example, when you do, now let us take this addition reaction. If you take the ketone, so if you do the addition reaction, hydrogenation, for example, you take chiral ruthenium catalyst, do the hydrogenation, and if you get only one enantiomer, for example, after hydrogenation, you will have this. If you get single compound, you can call it as this one stereo. This is enantiospecific reaction. Enantiospecific reaction. And if you get mixture of these two, for example, you have this is 80%, the other one is 20%. For example, you have 20%. This is enantioselective reaction. If you get only one, this is you should not be confused. Okay, if you get only one compound, this is enantiospecific reaction. On the other hand, if you get only one compound, if you get a mixture, one compound enantiospecific, on the other hand, you get mixture of both. This, let us see, 80% you have, another one you have 20%. So this is an example for enantioselective reaction. 80 minus 20, you will get 60% enantiomer excess. So this also you can call it as stereospecific reaction and stereoselective reactions. And another example, I have an enantiomer. For example, you have the hydrogen here. And you have OTS here. So you add a nucleophile, it undergoes substitution reaction. If undergoes SN2, you completely get this compound. So with inverted configuration, you call it this one stereospecific reaction. On the other hand, you may also end up with a mixture of compound, maybe 90% of this, another 10%, another enantiomer. You can call it a stereoselective reaction. Regiospecific and chemoselective reactions. Chemoselective means you take a mixture of two carbonyl compound. For example, you take benzaldehyde, another one you have the ketone. So both can undergo addition reaction. When you react with the nucleophile, suppose it selectively undergoes reaction with this aldehyde without affecting the ketone, you can call it as chemoselective. This is an example for the aldehyde readily undergoes reaction. So ketone doesn't react here, then you can call it as an example for chemoselective reaction. Regioselective reactions are regiospecific. Now let us take the substituted benzene ring. You have here substituent here. Now if you can selectively react, you have here a substituent, another substituent here. If you functionalize, you have two CH bond. The one of the CH bond using this, you can try to selectively functionalize this CH bond compared to that, then you can call it as because you have 4 CH bonds, you are trying to selectively functionalize this CH bond, for example, with a functional group. Then the other hydrogens are intact, the W is here, then you can call it as a regiospecific reaction. On the other hand, you may also end up with a mixture of compound. For example, this CH bond can be converted to this. In addition to that, this CH bond also can undergo reaction. Although you have substituent here, it may be less reactive. Then you can call it as regioselective reaction. You will end up with a mixture of compounds. One will be the greater comparing to the other. In that case, you can call it as regioselective reaction. Hello, this question can you find out this one? In week 4 assignment, question number 10. Week 4 assignment, question number 10. Why the COO Li is not attacked first? Iodine containing reagent. Open that book. No, here the question number 10, it involves 3 steps. First, what happens here? You have to react with N-butyllithium. So, as you know well, when you react with the carboxylic acid, with the N-butyllithium, you can look at here, 2 equivalent of N-butyllithium is introduced. When you react, you make a salt. One equivalent of N-butyllithium will react with the carboxylic acid, you make this salt. Now you have the acidic hydrogen, the another n-butyl lithium. It can deprotonate this, and you will be able to form the this kind of intermediate. Now, once you form this one, then you add your alkyl halide. In this reaction, you are going to add alkyl iodide. Now, if you look at here, it acts as a nucleophile. It undergoes nucleophilic substitution here, then this will leave. You will be able to get the alkylated compound. It is two-step reaction. First, what you do, you add 2 equivalent of your n-butyl lithium. You will be able to form the carbon ion, which acts as a nucleophile which undergoes substitution reaction with this alkyl iodide. To give this salt, which when you do the workup, and you will be able to get the carboxylic acid as a product. What is the exam product in that? First one, huh? Okay. Question, no? What? Oh, the answer is no, the answer is incorrect. What is that? Which one you gave? Which answer we gave? Would like to listen the lecture. So what is that? So I think that answer is D is the answer, right? Because it can go below what is it? That's right. That's a D is the answer. But what? No, the answer is incorrect. What is the oh. But another is that's right. But what is some student asked questions, right? What is it? Maybe we have to write. Let's check it. Write it. I would like to listen to the lecture. But,
not properly written.
oh, this right now, just now you wrote. This But how do you write it? Write to him because we are not able to understand some of the things. See, about this reaction, interaction is written the student. We don't know. If you are,
So you tell them that.
okay, there is a number 9. A student is written about this interaction. I am not able to understand. Can you write, elaborate?
So there is a question in chat box.
This is question and answer. This question.
Oh. Yeah, we will do it. So, what is the question number?
Hani Sharma just replied in the YouTube live.
Okay, that we will send it. So that we have to check. See, that may be reduction. So everything recorded we have to. Okay, this we have to check and write to later. That we will do. No, that also we will do later. Okay, that we will try to explain the next live session.
So can I keep the end?
Done.
You can finish. Just 10 more.
If no more questions, let us take leave and we will try to connect the next live session, whatever you have doubts, and you can keep it. We will try to explain. We have to